Okay, in this video we are going to cover simplification of logarithmic expressions. Before we start simplifying logarithmic expressions, let's write down the main properties of logarithms, and that is logarithm b by base a to power c is equal c times logarithm b by base a, and that's logarithm b, well, under a condition where b to power c is greater than 0. Under logarithm we cannot have negative number, therefore I'm going to put this b as an absolute value. Okay, next one. All right, let's go through multiplication. Logarithm ab by base, let's say what? Lowercase a is equal logarithm absolute value, logarithm a by base small lowercase a, and plus logarithm b by base a. Same way division, logarithm a divided by b. Well, let it keep also by base a. It's going to be equal logarithm a by base a divided by logarithm b by base a. Okay, change of the change of base. If we want to do change of base, we have logarithm n by base a. I can change by base b. It's going to be logarithm n by base b divided by logarithm a by base b. Also, if we have logarithm b by base a, I can switch to 1 over logarithm a by base b. And lastly, if we have a to power logarithm b by base a is equal b. Okay, so we have here all these main properties. And let's start working. So, problem number 1. We have logarithm b by base a plus logarithm a by base b. See, once you look at these two logarithms, you can notice that I'm going to use this property, right? And plus 2 multiplied by logarithm b by base a and minus logarithm b by base ab times logarithm a by base b and minus 1. Okay? So, one thing you need to know, we cannot do any operation with logarithms unless the base is the same. And this is our base, a and b. Those are our bases. All right? So my goal is to convert the different bases, convert into same base, using this the property. Okay? This is going to be logarithm b by base a. I'm going to turn everything into a logarithm by base a. So here it's going to be plus 1 over logarithm b by base a. See, I switched with these positions, okay? And plus 2. And multiply by logarithm b by base a and minus, here I'm going to do changes, see, instead of a we have ab, right? And I'm going to do change by a logarithm, by base logarithm a. Here it is, this one, let me change here this function. I'm changing the base, and it is going to be, I'm going to use base a, logarithm b by base a over logarithm ab by base a, and times 1 over logarithm b by base a. Okay, let me, this one also changing because we use different, and minus 1. Okay, so what do we have here? Let me see. This in first parenthesis, I'm going to bring to common denominator. Logarithm base by the logarithm b by base a. So it's going to be logarithm squared b by base a plus 1 plus 2 logarithm b by base a. What do we get here? Look, we get x squared plus 2xy and plus y squared. Perfect square, right? Okay. And multiply. Let me clean this. Once we get here perfect square, let me write down before I continue. It's going to be logarithm b by base a plus 1 squared, right? Over logarithm b by base a. Okay, so let's continue here. What is going to be here? Logarithm b by base a minus logarithm b by base a. In denominator, I have product. So I'm going to convert into addition, right? Here it is. Okay, and we are getting logarithm a by base a plus logarithm b by base a times 1 over logarithm b by base a minus 1. Okay, so we are getting, one second, let me make it more compact. Okay, so we are getting logarithm b by base a plus 1 squared times, here we take common factor out in the second parenthesis, and it's going to be logarithm b by base a. So what will be left in parentheses here is 1 minus 1 over logarithm a by base a, or rather saying, let's put 1, might as well, because this is 1, right? Logarithm a by base a. And then I can write down here logarithm a by base a is 1. A to power 1 is equal a, right? Okay, so back it's going to be 1 plus logarithm b by base a times 1 over logarithm b by base a minus 1. So what we have here, if this logarithm b by base a, oops, too thick, I'm going to cancel with this 1 logarithm b by base a, okay. Next, let me see, logarithm b by base a plus 1 divided by logarithm b by base a to power 2 and times, here I'm going to bring to common denominator 1 plus logarithm b by base a, and it's going to be 1 plus logarithm b by base a and minus 1, and here is minus 1. So as a result, this is gone, right? What can I do also? I have here logarithm b by base a plus 1 squared. I can cancel this with this, right? What else I can do? I have logarithm b by a base a, this one, I'm canceling with this one. And as a result, what is going to be here left? It's going to be left logarithm b by base a plus 1 and minus this one. So it's going to be this piece and a minus this one. And the result is logarithm b by base a. Okay. Moving to next one. We have 1 minus logarithm cubed b by base a and divided by logarithm b by base a plus logarithm a by base b plus 1 and times logarithm a over b. Okay, how are we going to start? First of all, this is going to be a formula, a cubed minus b cubed, right? To remind you real quick, a cubed minus b cubed is equal a minus b and a squared plus ab plus b squared. And if you have here plus, then this is going to be plus and this is going to be minus. Okay, so what do we get here? We are going to get 1 minus logarithm b by base a and then times 1 minus, no, plus logarithm squared b by base a. Okay, let me go first this ab, which is going to be logarithm b by base a, and only then plus. I just want to follow the formula of, although it's not a mistake if I switch, it's addition, but so some students people won't get confused. Logarithm b squared by base a, okay? We're dividing by logarithm b by base a plus 1 over logarithm b by base a. I'm switching the base, right? And okay, hold on. Yeah, and plus 1 and times, since we have here division, then it's going to convert into subtraction, logarithm a by base a and minus logarithm, here's supposed to be a, minus logarithm b by base a. Guys, at the beginning here it's supposed to be base a. I didn't put it in original problem. Forgot or missed it, whatever. So from here, we are getting, what we're gonna get from here? Let me see. Since logarithm a by base a, it's 1. I mean this color, let me use this color. It's 1. So we are getting what? We are getting 1 minus logarithm b by base a, and we are getting 1 minus logarithm b by base a. Correct? And as a result, we are going to get 1 plus logarithm b by base a plus logarithm square b by base a and divided by logarithm squared b by base a plus 1 plus, I'm bringing to common denominator here, plus logarithm b by base a over logarithm b by base a, right? And this is gonna be, what is gonna happen here? This I can cancel with this, right? And as a result, I'm going to end up with logarithm b by base a. And this is going to be my answer. Why is not fractional? Because when you divide the whole part a, you make this division b by a by c, what's going to happen? A times c over a, right? A and a is gone, we get c left. And that's our logarithm b by base a. Okay, let's solve the third one. Third one is a really interesting case. All right, we have 25 to power 1 over 2 logarithm 25 by base 49. Okay, plus 2 logarithm 2 logarithm 2 logarithm 2 a to power 2 logarithm 4 by base a, and all this times 4 to power negative 2 over logarithm 4 by base 3 and minus a squared. And we divide by 1 minus a. Okay. So, using the property I placed at the very beginning, and I'm going to write down here. So, I'm going to use this doing drafting 1 over 2 logarithm 25 by base 49. This is this one. Okay. Okay. I'm going to, since I have here 25, I'm going to switch this base, and I'm getting 25 1 over 2 log 49 by base 25, right? Okay. And what do we have? This multiplication. So this is, I'm going to write down 25 times 1/2 times 1 over logarithm 49 by base 25. This logarithm 49 by base 25, let me rewrite it. 29, it's equal 49, right? It's going to be equal 49, correct? Okay, we are getting 49, and this 1/2 will stay. Yes, and that is equal square root 49. Okay, it's going to be equal square root 49, which is equal 7. Yes, so let's write down all this. So what do we have here? I'm going to write down 25, write down 1 over logarithm 49 by base 25 and times 1/2. Yes? Okay. Now this is we're going to work out separate. 1 minus a plus. So what we are going to get here? 2 plus 2 logarithm by base 2, another logarithm by base 2, and here we are going to get, let me see, this logarithm, a to power 2 log 4 by base a. Let me rewrite, oops, I want to rewrite this a again, so it will look like a, so it won't cause any confusion, right? So what is going to be? It's going to be logarithm 2, and then logarithm by base 2. It's going to be 4 squared, right? Because 2 logarithm 4 by base a, and here is a, is equal a to power logarithm 4 by base a, and this 2 comes here as a degree, right? Based on formula, based on properties of log. And property says logarithm a to power p is equal, this p comes in front and you get p times logarithm a. Now you have this form, p times logarithm a, going back, and it's coming as a exponent. Okay? So we get, this is going to be equal 4 squared. Okay? Here we have 4 squared. Okay. So, and all this multiplied by 4. Can we do some changes here? Yes, -1. I can put here -1 times 2 over, and I'm switching logarithm 4 by base 3. I'm switching logarithm 3 by base 4. So I can have this operation. Look. Right? And what we have, minus a squared. Let me move this. Okay. Minus a squared. And actually I need to squeeze this one a little bit. There we go. Okay, now I'm going to work out this, okay, let's work out. I'm going to work out this 2 log 2, and blah, blah, blah. So it's going to get 2 log 2 log 2 log 2 4 squared. It's going to be equal to logarithm 2. Well, I can put parentheses. Logarithmic meaning they are built in. Okay, logarithm into logarithm. And here we are getting 2. This square comes in front, right, based on this rule. 2 logarithm 4 by base 2. Okay, and that is going to give us 2 logarithm 2 logarithm 2, and this is going to be 2 times logarithm 4 by base 2 is equal to, right? Look, logarithm 4 by base 2 is equal to, right? 2 to power 2 is equal 4. Okay, and this is equal 2 times 2. Yes? Okay, 2 logarithm 2 in parentheses logarithm 2 by base 4. So this is going to be equal to logarithm by base 2, and this is going to be equal to, right? Logarithm 4 by base 2, it's going to be equal 2, which is going to be equal 2 times log 2 by base 2, it's 1, right? Because we have log a by base a is equal 1. Log a by base a is equal 1. Let me clean this drafting so we can have only formulas right here. And we clean this piece also. Well, this one is kind of long, so explanation, I'll let it sit because we worked out and we just used the answer. Okay, so we get 2 times 1, right? And the whole this chain of logs, we simplify down to 2. All right. Now, what we are getting from this first part, 25 to power 1 over 49 by base 25 and times 1/2. That is going to be equal. This piece that we have, this piece is going to be equal 49, right? 49. Oops. 49 by base 1/2, correct? Yes. And plus the whole this 9 yard of logs is equal to, correct? Let me clean this one also. (49) times, this is 25, and parentheses. Okay, plus 2, right? And we need to multiply. What do we have here? This one is also gonna be what? It's gonna, we're gonna end up, since we have 2, right, and 4 to power -1 times, I'll tell you what, I will do these type of changes. Yeah, instead of -1, I will take out -2 and leave here 1 because I'm going to switch. Okay, here I'm going to leave -2. Look here, 2 log -2 log 4 by base 3. So I took out -2 and I'm getting here, it's going to be 3 to power -2, right? It's going to be 3 to power -2. and minus our a squared, right? From here. Okay, dividing by 1 over 8. All right, so what do we get? 49 to power 1/2, that's the square root of 49, right? Which is equal 7. 7 plus 2 times 3 to power negative 2, it's going to be 1/9 minus a squared, and divided by 1 minus a. So 7 plus 2 is 9, and over 1 over 9, it's canceling each other. Yes, and we are getting 1 minus a squared over 1 minus a. So result is 1 minus a is gone, and here will be left 1 plus a, correct? Because 1 minus a squared, it's 1 plus a, 1 minus a. And the final result is going to be 1 plus a. Okie dokie, I'm done. As always, thank you for watching. If you have questions, you can put in the comments. And I'll see you next video.